Welcome guys, in this video we will do an example related to test of hypothesis. Now this particular example is related to X square test, and this example was asked in your GTU winter 2019 examination. So the question says records taken of the number of male and female birth in 830 families having 4 children are as follows. So in the question we are given a table. First row says number of male birth. Out of 4 children, 0, 1, 2, 3, 4 numbers represents number of male births. Second row represents number of female birth. And third, number of families. So 32 families has 0 male and 4 female. 178 families have 1 male child and 3 female child out of 4 children. Now in this question we have to test our hypothesis that whether this distribution follows binomial or not, whether binomial law holds or not, that we have to test. The chance of male birth is exactly equal to female birth, that is P is probability of male birth and Q is probability of female birth, then P is equal to Q is equal to half. Now in this question, value of x square at 5% level of significance and for 4 degree of freedom is 9.49. This data we will use in our calculation. So to do this example, we have to consider 6 steps. So first step is null hypothesis. That means we are assuming that binomial law holds. And alternative hypothesis is, if these hypotheses do not work, then we will assume that our alternative hypothesis works. That is, binomial law doesn't work. Doesn't holds. And in each and every example we will assume level of significance 0.05. But in this question it is already given that 5% level of significance, that means 0.05. So level of significance alpha is equal to 0.05. It is given in the question, and if not given we will assume, and always assume 0.05. Now this step 4 is very much important, so let me erase, and it is long step, so I will need more space. So for step 4, first we will write total number of families, that is n, 830 families, and we have to check binomial distribution law. So we will write equation for binomial distribution, NCX P raised to x Q raised to n minus x. In this case n is number of childrens, that is 4 number of childrens, that is given in the question, 4 children, and P and Q are equal to 0.5. So we will plug this data in this question. So there are total 4 childrens and P and Q are equal, so 0.5 raised to x and 0.5 raised to 4 minus x, n is equal to 4. Now guys, you can simplify this term and you can write 0.5 raised to x plus 4 minus x. So x will get cancelled out and you will get only 4, 0.5 raised to 4. So this is equation for Px, probability of x number of boys or male birth. Now after doing this calculation we have to construct 2 tables. So in first tables, number of males, that is x, an expected number of expected frequency, that is Fe. Now we will write all the possibilities of number of males out of 4 children. So it is possible that no males at all, 1 male, 2 males, 3 and 4. And now to determine expected frequency, we will multiply this probability of X number of boys with total number of families, 830 families. So 830 times Px is 4Cx 0.5 raised to 4. Now this equation is important. So for x is equal to 0, we have to calculate number of Fe. So if you put x is equal to 0 in this equation, then you will get 830 times 4C0 0.5 raised to, this is multiplication, 0.5 raised to 4. 4C0 is 1. So 830 times 0.5 raised to 4. So you will get approximately 52. You have to round your answer to the nearest digit. And frequency is always integer, so you don't have to write in decimal places. So you have to round up your answer in nearest integer. So it is 52 in this case. So I will write 52. And always, as binomial distribution is symmetric in the particular case of P is equal to Q, so for symmetric cases 52 will be here also. That is, probability of 0 boys is equal to probabilities of all 4 boys. Now if you put x is equal to 1 in this equation, you will get Fe is equal to 208. You just have to put x is equal to 1 in this equation. And as binomial distribution is symmetric for P is equal to Q, this is also 208. Now we will put x is equal to 2 in this equation, and you will get value of Fe as 310. So this is our table of x and Fe. Now after constructing this table, we have to construct another table. And this table will give us value of x square. So this table has total 1, 2, 3, 4 and 5 number of rows. So number of male F0 is observed frequency, that is given in the question. Fe is expected frequency, that we have calculated. F0 minus Fe, and finally Fo minus Fe whole square divided by Fe. Now number of males 0, 1, 2, 3 and 4. Observed frequency is 32, 178, 290, 236 and finally 94. Expected frequency we have calculated, that is in the previous table, that is 52, 208, 52, 208 and 310. Now you have to subtract Fe from Fo. So 32 minus 52, it is minus 20. 178 minus 208, it is minus 30. So likewise you have to create whole column. You have to calculate data of this whole column and you will get this. Now you have to multiply this value and you have to divide this multiplication by Fe. So 20 square divided by 52. 20 square divided by 52. So you will get 7.69. 30 square divided by 208. It is 4.33. Then 1.293. 33.77 and 33.92. Now you have to sum up all these values and you will get x square is equal to 51, exactly 51. So this is completion of our fourth step. Now we will move to fifth step. Fifth step is critical value. It is V. It is also called as degrees of freedom. So it is n minus 1. N is total number of columns in this table. 1, 2, 3, 4 and 5 columns. So 5 minus 1 is equal to 4 degrees of freedom. So for 4 degrees of freedom, value of x square at 5% level of significance, that is 0.05, is 9.49. And x square value which we had calculated was 51. This value was calculated using table. So fifth step we can write like this. This value is of course greater than this value. So as x square is greater than, we will write since x square is greater than 0.05 at 5% level of significance, the null hypothesis is rejected. So our first hypothesis, that was null hypothesis, is rejected. Null hypothesis is rejected. And hence, therefore, the data do not follow binomial distribution. Therefore, data don't follow binomial distribution. So guys, this is end of our example. I hope you like this video. Please like, share and subscribe, and thanks for watching.